Hello, year eights, and welcome back to Maths and Science in Action. We're in a bit of a predicament with online learning, but so what I'm going to be trying doing for our math lessons is I'm going to be posting up videos online for you to watch, and also posting up a few questions for you to have a go at home as well, which are based on the stuff that we go through in the videos. So each of the lessons, what I need you guys to do is to have a watch of the video that I'm posting up on Google Classroom, and then have a go at the questions that I post as well. So that's my plan for maths and science in action. Unfortunately, we're in this lockdown scenario and we're doing this online learning thing. So I hope you're staying safe wherever you're at, and that you are staying well and just doing well yourselves, year eights. What we are doing in mathematics is, in the mathematics portion of Maths and Science in Action, is we're starting this topic of fractions, decimals, and percentages. Fractions, decimals, and percentages are numbers that we encounter in our everyday lives, all around us. Whether that be in dealing with money, whether that be dealing with like sales at the shops, whether that be dealing with just splitting things between your friends. So what we need to be able to do is operate with each one of these different types of ways of writing numbers. And so here we're going to be talking about fractions in this first part. And so in today's lesson, we're going to be talking about equivalent fractions. And so what we want to be able to do by the end of this lesson is two things. One, if you have a look on the screen, up there, convert equivalent fractions and also simplify fractions. Those are the two things we're going to do in today's lesson. So let's talk about fractions today. So if you have a look, let's just quickly go through what a fraction is. Now, a fraction is just a number. So fractions represent numbers, and this is when a whole number is divided into equal parts. So imagining a whole, and so in primary school you might have talked about a circle representing a whole or a bar representing a whole, and we're just splitting it up into equal parts. And there are two parts of a fraction. So there's two parts. I'm actually going to talk about a third just as a fun bit of trivia. But there's two parts of a fraction. Now, the number at the bottom, this number over here. So I've got an example of a fraction here. I've got 3 over 4, or sometimes you would also call this 3/4. We're going to first talk about this number over here at the bottom. This number here at the bottom is called our denominator. So the number at the bottom, and we talked about this in algebra a bit, denominator. So that's our number at the bottom. Now this tells me how many parts the whole was divided into. The whole was divided into. So this 4 tells me that I took a whole and I divided it into 4 parts. So I took a whole and I divided it into 4 parts. Okay, so that's our denominator. It tells me how many parts we've divided into. Now, the number at the top, this guy, you may recall, is called our numerator. The numerator tells us how many parts we were selected. So, how many parts selected? So, let me write that down here. How many parts are selected? Oh, can't spell. Selected. So, there we go. And so these are the two parts of our fraction. We've got the numerator and the denominator. Now, in algebra, I also told you that fractions represent division. And here, it's still the same thing. We're dividing, this 3 over 4 is just another way of writing 3 divided by 4. And it just happens to result in this number, 3/4. Now, there's a third part of our fraction, which is this line in the middle. And I think I also mentioned this last term, but this line in the middle has a special name. Doesn't have any meaning to have anything else attached to it, but it's called a vinculum. And that's just a fun bit of trivia. If you ever want to ask someone, what do you call the line in the middle of a fraction? It's called a vinculum. And so those are the parts of my fraction. Fractions are just numbers which are formed when a whole number is divided into equal parts. And we've got a numerator and a denominator. The numerator tells us how many parts we've selected, and the denominator tells me how many parts there were all together. How many parts it was divided into. Okay, so that is what a fraction is. What we need to do is we need to work with equivalent fractions. So that's what we're going to be talking about in this first part of the lesson. So equivalent fractions. I have a quick definition here of what an equivalent fraction is. So equivalent fractions are fractions with different numerators and denominators. So they might not have the same numerator and denominator, but they are equal in value. Let me write this correctly. So what equivalent fractions are? These are just fractions which, even though they may have different numbers at top and different numbers at bottom, they represent the same value. So here I've got an example to show you this. So I'm going to start off on my left hand side. I've got 1/2 or a half. Now if I have underneath, I've got a circle. I'm just going to represent a half on my circle. So I'm going to split my circle into 2 parts, and the half I'm splitting into 2 parts because that's what my denominator tells me. And the 1 at the top tells me that I've selected one of these halves. So here, I've selected this half. So this here is my half. Now we could also write this as a fraction out of 4. Now, if I divide my whole into 4, which is what the second fraction is, I'm splitting it into 4 parts. Now, if I want to represent the same value, if I want to have the same amount of stuff that's shaded as my first circle, well, I'm not just going to have 1 part selected out of my 4. I need actually 2 parts. And so by selecting 2 parts, I've actually got the same value. We've got the same amount shaded, but we've got different numerators and denominators here. Hopefully you're starting to see that. And we can continue this. We can keep going for as long as we want. I've only done 3 here. So let's do the third one. If I've got a denominator out of 6, and so I'm splitting up my fraction into 6 equal parts. Let's hope that I can draw this into 6 equal parts. Almost close enough to 6 equal parts. I still want to have the same amount of area shaded as the first 2. Well, if I need to do that, I need to select 3 parts instead of 1 or 2. So here, 1, 2, 3 will get me the same amount of space shaded as the first 2. 3/6. So that's what it means to have equivalent fractions. These 3 fractions, they've got different numerators and denominators, but they all represent the same value. They all represent the same value. So you could continue going on for this forever. I could go do 8, 4 out of 8. I could go out of 50, that's 25 out of 50. You could keep going on and on and on forever. You can create as many equivalent fractions as possible. The reason we need to know this is because when we're operating with fractions, which we're going to cover in the next lesson after this, we need to sometimes make it so that our denominators are the same. We need to make our denominators the same. And so we can actually convert our fractions, because they're all the same value, we can convert them from one fraction to another fraction because they are equivalent fractions. And so that's what we're going to be doing in this next section. So these are the steps we need to follow when we are creating equivalent fractions. So here, these are the steps we're going to do. First step, identify what your target numerator or denominator is. So the first step that we're going to follow when we're trying to create equivalent fraction is figure out what is our target. What do we want to change and what do we want to make in our target fraction? Do we want to have a denominator of 50? Do we want to have our numerator to be 1? We need to actually identify what that is. And most often, you're going to be changing your denominator most of the times. Okay, the second step then is to find the number that you will need to multiply or divide the starting fraction's numerator or denominator by to get the target. So we have a look at our starting fraction and we go, okay, if we want a target denominator of 50, well, what number do I need to multiply my denominator by to get me 50? Or divide my starting denominator by to get me 50? Or similarly, if I want to have a target numerator of 1, I need to go, okay, what number do I need to multiply or divide my numerator to get me 1? And then once we've done that, the final step is then we have to multiply both the numerator and denominator by the same number. So once we figured out what that number is, we need to apply the same thing to both our starting numerator and denominator. We need to apply the same thing to our starting numerator and denominator. So let's have a go at a question where we do this. So let's have a look here. Example 1, creating equivalent fractions. Rewrite the following fractions so that they have a denominator of 40. So what we want to do in all of these questions is have our fractions have a denominator of 40. So we want to write our fractions as over 40. So let's have a go at these questions. I don't know why there's a spare B here, just ignore that for now. We've got 3 out of 5 for our first fraction. So we've got 3 out of 5 for our first fraction here. Apologies about that noise. We want to write this as a fraction over 40. So we want to write this as a fraction over 40. So what we want to do is we want to change our starting denominator of 5 to become 40. So we need to multiply it by a number. Now, a few of you have got your times table in your head, and you can think to yourself, okay, what do I need to multiply 5 by to get me 40? And so in your head, some of you are already thinking, I know that number. That's just timesing it by 8. So if I want to go from 5 to 40, then I need to multiply by 8, which is exactly right. So there we're going to, I just realized I just renumbered it, but that's okay. I need to multiply by 8, which is exactly right. Now, if I've done this in my denominator, I also need to do this in my numerator. I need to actually go, I can't actually split this. This isn't good. No, let me just ignore it for now. I need to also do the same multiplying by 8 to my numerator. So what I need to do is I need to multiply my numerator also by 8 to create an equivalent fraction. Because if I don't multiply by 8, the value of my fraction actually changes. And I don't want to change the value. I just want to keep the value the same, but just change it to become an equivalent fraction. So here I'm going to multiply the numerator by 8 as well. So I'm going to do 3 times 8. 3 times 8 is just 24. If you're not sure how to do this, you can chuck a calculator out and figure it and put it in to give you that number. Now, if you're not quite sure how to get this number of timesing by 8, another way that you can think of this is, I'm going to do it over here. The way I do this is, well, I just think of what's the opposite operation of multiplying. The opposite operation of multiplying is dividing. So what I can do is I can take my finishing denominator, so the target denominator that I want, I go 40 and I divide it by the starting denominator. So I'm going to divide that by 5. And so here I go 40 divided by 5. That just gives me 8. And so that's the number that I need to multiply by in order to get me from 5 to 40. So that's how we create an equivalent fraction for this first example. Hopefully that made sense to all of you guys. Let's have a look at the next one. The next one we've got, I'm just going to move it down so I have a bit more space. They're renumbered, but that's okay. I've got 1 over 2. I've got 1 over 2 and I want to rewrite this as a fraction over 40. So just like we did in the previous question, we want to find the number to multiply my denominator by to get me from 2 to 40. So 2 to 40, if you're not quite sure about your times tables, we can actually work backwards. So if our finishing is 40 and we start off with 2, we can just go 40 divided by 2. 40 divided by 2 gives me 20, which means I need to multiply the denominator by 20. And I also need to do the same to the top. So I need to do 1 times 20. What's 1 times 20? That just gives me 20. So the equivalent fraction of 1 over 2 as a fraction over 40 is just 20 over 40. Okay, next one. Next one, we've got this question of 7 over 4. 7 over 4. Okay, 7 over 4. And once again, I want to write this as a fraction over 40. I want to figure out what number I need to multiply 4 by to get me 40. Now, some of you can do your timetable once again. That number happens to be 10. So to get from 4 to 40, I need to multiply by 10. And the other way you could do this, once again, I'm just going to do the extra working out. 40 divided by 4 gives me 10. And I can check that on my calculator. Give me 10. Excellent. So if I do that to my denominator, I can't just do it to my denominator. I want to keep the value the same, so I need to do the same thing to my numerator as well. So I'm going to go to my numerator and times it by 10. 7 times 10, that will give me 70. So if I want to write 7 over 4 as an equivalent fraction over 40, that just becomes 70 over 40. Okay, now last example here. So the fourth example here. I've got 36 over 120. Now here, and I want to write this as a fraction over 40. Now, compared to all the previous ones, notice here, all the previous examples, all of the denominators have been smaller than 40, which is really nice because that tells me I need to multiply. This time, because the starting denominator is bigger than 40, we need to divide. And so whatever we divide the denominator by, we also need to do to the numerator as well. Same thing as the questions that we did before. So I want to find a number that when I divide it into 120, it'll leave me with 40. Now, hopefully you can start to see this. Okay, I can go, okay, 120 divided by 40 will actually give me, well, what does that give me? 120 divided by 40 gives me 3. And so the number that I need to divide 120 by to give me 40 is dividing it by 3. So if I do that to the bottom, I need to ensure that I do the same thing to the top. So here, I'm going to divide by 3. I'm going to go to my calculator. 36 divided by 3, that gives me 12. And so the equivalent fraction over 40 is just 12 over 40. So that's how we create equivalent fractions. We figure out what number we need to multiply our numerator or denominator by. So most often you're going to be dealing with a denominator change. And then once we figured out that number, we need to do it to the denominator so that we can get our target denominator and our numerator as well. So we need to ensure that we do that operation, multiplying or dividing to both the numerator, the denominator and the numerator. So that's how we create equivalent fractions. That's the first part of today's lesson. The second part is we want to also simplify fractions. So let's just go through this next part. So simplifying fractions, I have a definition here. The simplest form of a fraction is the, what's it called? Is the, let me get my notes out, equivalent fraction. I knew this. Equivalent fraction. With the smallest possible whole numbers in the numerator and the denominator. So, hopefully you've noticed that we can actually create a whole bunch of equivalent fractions, and they all have the same value. The simplest form, or the simplest fraction, or when we simplify fractions, what we want to do is we want to find the smallest possible way to write our fraction. We don't want to write 100 over 200. That's actually really annoying to write. What we want to do is find the simplest way of writing that. So we just go to 1 over 2, for example. So this is similar. We're still going to apply the similar steps of equivalent fractions that we did before, but this time we're going to be doing a lot more division. Now, the way that we do this, the steps that we have, is we want to identify the highest common factor of the numerator and the denominator. So we want to find the biggest number that can divide both the numerator and the denominator. The biggest number that can divide both of the numbers at the same time. And then once we do that, we want to divide the this HCF number from both the numerator and the denominator. So when we're simplifying fractions, it's similar to creating equivalent fractions, but we're dividing. We're dividing so we can actually go down to the smallest possible whole numbers available to us. So we're going to have a go at 2 examples of this. Let's have a look at these 2 examples. Write the following fractions in simplest form. Okay, so I've got 2 fractions here. I've got 8 over 20 and I've got 25 over 15. What we want to do is we want to find a number that can go into both 8 and 20, and we want to find the biggest possible number. So we actually did this when we were looking at algebra and simplifying algebraic fraction, or dividing algebra terms. What we want to do is we want to find numbers that can go into both of these numbers. So have a look at 8 and 20. Now 8 and 20, I know that in my head that when I think of my times tables to get me to 8 and get me to 20, both of them have a common factor of 4. And 4 just happens to be the highest common factor of both of them. So what I can do is I can write 8. 8 is just the same as 4 times 2. And the bottom, this is just the same as 4 times 5. And so now that I've identified that they have a highest common factor of 4, I can cancel this out or divide it out from both the top and the bottom, and I'm just left with 2 over 5. And so that's how we simplify these fractions. We want to find the highest common factor, a number that can divide both my 8 and 20, and then cancel it out or divide it from both of them. Now, if you can't find that number, what you can do is you can find any factor, any number that can go into both 8 and 20 and divide it from them too. So for example, if you're not able to jump straight to 4, you might go, okay, 8 and 20, both of them are even numbers. I know that even numbers can be divided by 2. And so what I can do here is I can go, okay, 8 is just 2 times 4, and 20 is just 2 times 10. And so I can just cancel that 2 out. So here I can cancel out, and I'm left with 4 over 10. But then you look at 4 over 10 and you go, okay, hang on, can I go any further with that? Well, 4 and 10 are both even numbers as well. So I can actually take out another 2. So here, 4 is just 2 times 2, and 10 is just 2 times 5. And I can cancel out that 2 again, and I'm left with 2 over 5. And so that if you're not quite able to find the highest common factor immediately, what you can do is you can actually go backwards and look at and go step by, you can repeat this process of finding any possible common factor. Okay, the other one. Here we've got 25 over 15. Now, 25 over 15, we want to find a highest common factor that goes into both of them. If you think about both of these numbers are factors of 5. So here, 25 is just 5 times 5, and 15 is just 5 times 3. And so what I can do is I can cancel out one of these 5 from both of these terms, and I'm just left with 5 over 3. And now I need to think about 5 and 3. Is there any number that can divide into 5 and 3? Now some of you might say, well, 1 can divide all numbers, so I can actually take out 1. Well, if you take out 1, it doesn't actually do anything. Let's just show you how that. So 5 is just 1 times 5, and 3 is just 1 times 3, and I can cancel out that 1. I'm still left with 5 over 3, so it doesn't really do anything. So here, I'm at my simplest form. Now, if you're able to start to get the pattern of this, and start to get these highest common factors really easily, what you can actually do is you can go, okay, the quick way that we write this is I can go, okay, cool, I can cancel out that common factor. I notice it's 5, and so when I divide 5 from 25, I can just write the remainder 5. And when I divide 5 from 15, I have a remainder of 3, and so here I've actually got 5 over 3. That's a quick way that you can actually do this once you start to get the hang of it. So that's how we simplify our fractions. So hopefully this quickly explains to you guys how to go through finding equivalent fractions. So equivalent fractions, what we want to do is find the number to multiply either our numerator or denominator to make our target numerator or denominator. Then we need to do that same multiplication or division to both top and bottom. Then when we're simplifying, what we want to do is we want to find the highest common factor and divide it or cancel it out from both the top and the bottom. So with that, hopefully you should be able to have a go at the questions that we've posted on Google Classroom. If you have any questions, feel free to post it up or send us an email. We're more than happy to try and answer them for you. And if you need to go back and watch any part of this video and slow it down and just re-watch it, you can do that as well. That's it for this lesson, and we'll see you guys next lesson, year 8, and I hope you're staying safe wherever you are. Bye.